Hey guys, Aeonhack here, and this is part 4 of the Server Client Applications video tutorial series. Today I'm going to be showing you how to set up a secure connection with your sockets using RSA, which is public key encryption, also known as asymmetric encryption. And I know it sounds kind of intimidating at first, but don't worry, it's pretty simple. However, we do have a lot to cover, so I'm going to move kind of fast. If you missed something, just pause the video and look over it. So the first thing we need to do here is create a new instance of RSA in our server. So right here above submain, where I have my listen code and stuff, I'm going to declare that. Or, sorry, no, rather I'm going to do it over here right under Packer. So private RSA as new, and actually scratch that. We need to import system security cryptography first. There we go. So private RSA as new RSA crypto service provider 2048. The 2048 here represents the bits, and generally the higher that is, the more secure it is. 2048 is considered military grade encryption. So needless to say, it's pretty secure. It should definitely suffice. The next thing we need to do is declare like a public key here. So private public key as byte array. We're just leave that null for now. Now here in submain, we need to do RSA export CSP blob, include private members. False. We do not want to exclude those. Or we do not want to include the private members. Sorry, I'm confusing myself. If we were to do this, then the users would be sent the private key, and then they could decrypt everything, which would kind of defeat the purpose. So definitely be sure to set this to false, and we need to actually assign this to our public key. It's not actually a public key, it's a CSP blob, and it has a whole bunch of just information in it, but I'm going to refer to it as the public key, because most of the data within that blob is what makes up the public key. If that makes any sense, don't worry about it. You don't have to be a crypto analyst to understand. I don't know. Okay, so we set that there. We exported the CSP blob. And the way this is set up is the key is going to change every time we start the server. So if someone were to miraculously break the key, you just have to restart the server and it's secure again. But that is, I would go on a limb here and say impossible on our modern technology today. Maybe in like 20 or 30 years they could break it. Alright, so we export our public key here. Let's go down to our user class now and declare a new variable, public secure connection as Boolean. I'm going to actually move this under authorized just because I think it's a little easier to read. Okay, we need to create a new method here. So public prepare encryption. Yeah, we're just going to call it that. It's not really an appropriate name for it, but public sub prepare encryption. We have two parameters, key and IV, and we're just going to go up right above that here under secure connection. We're going to do private encryptor as iCrypto transform, and private decryptor as iCrypto transform. Okay, we're going to create a new instance of reangel manage, and we're just going to call it R. I call it reangel, it might be Ringel. I'm not really entirely sure on the pronunciation. But I think if you call it reangel encryption, people understand what you're saying, hopefully. And this is actually, at the time of this video, the AES, which is something encryption standard, which means it's good. So it's always a safe bet to use reangel. Okay, so now we need to create the encryptor and decryptor. So encryptor equals R, create encryptor, and then the key in the IV. Same thing over here at the decryptor. R, create decryptor, key IV. Okay, and then set secure connection to true. The reason we're doing it this way, instead of just having one method in our server that encrypts and decrypts, is because we want each client to have their own unique key. It's substantially more secure that way, and the reason we don't just recreate reangel manage every single time we want to encrypt or decrypt is obviously because it's very resource intensive, both in timing and CPU usage. So this would be the best way to do it. This is the preferable method. You are going to lose a little bit of memory per user instance, but it's definitely worth it. So just a little insight on that. Create two more methods here. So public encrypt data. I keep forgetting to declare these as sub and function. I don't know why. Data as bytes. And we're just going to return encryptor transform final block data 0 data length, and that just tells it to encrypt all of the data and send it back. Same thing down here for decrypt. Okay, good. And now let's go ahead and send a handshake packet. So we're just going to declare that up here in our packet header. Handshake equals 4. And when somebody connects, we actually need to make a new packet sender. Just going to copy this. Send handshake packet. Public key as bytes. Send the public key there. Change our header. Okay, and send it right here after they connect to us. We're going to send it to the client, and we're just going to send our public key. So this will send it to the client. It'll send the RSA public key to them the second they join, and then they're just going to respond back to us. So let's go on to the client for now. We're done here at the moment. For the moment, get the handshake packet header and add that to the client as well. Okay, now we also need to declare a encryptor and decryptor here in the client. So we can actually just copy and paste that as we do in every other video. We're just going to copy like everything we just wrote and paste it over here in the client code. Make a few adjustments to it. So we're just going to remove the perimeters on prepare encryption. Since we do not need a key, we're going to let reangel create one for us. Just right click that so it can fix the error for us, and that just imported system security cryptography into our client. Okay, and once we prepare the encryption, it sets secure connection to true. And we have our encrypt and decrypt methods here. Okay, so on read packet, case handshake, we need to handle that, so create a new packet handler for handshake. And we actually need to move the prepare encryption method, now that I think about it, but we'll do that here in a second. So private sub handle handshake. Let's comment this line out for now. And move all of this out of the prepare encryption method and just delete it and put it in here. Okay, so here we have our public key. So dim public key as byte, the public key the server sent us. Create a new RSA instance. Dim RSA as new. RSA crypto service provider. RSA import CSP blob, which is just the public key here. Alright. And then we need to go ahead and serialize that. So dim data as byte, packer serialize r.key and r.iv. And then go ahead and encrypt data with the RSA method there. Data equals RSA encrypt data, and set this to false, or true, sorry. Setting this to false will give you better compatibility, but honestly, you probably don't need to worry about it. It's just for compatibility on systems older than Windows XP. If you're communicating with them, half this code probably won't work anyways. So I really wouldn't be worried about it. Just set it to true, and it's apparently it's optimal padding. So whatever that means. I guess the data is smaller or something. I don't know. Honestly, could not tell you. And then once we have this, we have it all. Move that down there. Once we have this all set up, we need to go ahead and create a new packet sender because we need to respond to this server with our key and our IV that we just generated. So, soon handshake packet, and we're just going to reuse the same header. It's just easier that way. Change that perimeter to data. Okay. And then send handshake packet data. And then after we do that, we want to set the secure connection boolean to true. And I will show you guys why here in a second, if I remember, which I probably won't. So that's sent. That looks good to me. Let's go back to the server and handle that now. So if we receive a handshake packet, we need to create a packet handler for that. Handle handshake packet. Dim data as bytes. It's essentially just what we have right here, but we need to change the perimeter to 1. Let's go ahead and remove that for now. Okay, so when we get this data from the client and we deserialize the values, the second perimeter, is going to be the data blob that we sent there, which is basically just an RSA encryption, encrypted serialized chunk of data. Sorry, I know it wasn't that confusing in my head when I thought about it. So what we need to do here is decrypt this. So data equals RSA decrypt data and true. Make sure if you set this over here to true, you also do it right here. This little true on decrypt and encrypt. Okay, and now once we have decrypted it, we should be able to deserialize that. So dim perims as object array equals packer deserialize data And then we have our key as bytes equals direct cast prims 0 to byte array. And then we have an IV here, which is perimeter 1 or perimeter 2. And then we just initialize the encryption in our socket. So prepare encryption, key, and IV. And let me just make sure this is okay. Looks good to me. Okay, so now we have established our handshake. We both have the sets of keys. Now we just need to make some adjustments to our helper methods and our receive events. And I think I actually need to handle this down here really quick. Handle handshake packet, client, and values. Okay. This should be fairly easy to implement. We're just going to add a new line here to client read packet. We're going to add a try statement, try catch, just in case the encrypted data that they send us can't be decrypted with the keys that we have, indicating something has been corrupt or tampered with. We're just going to disconnect the client. Okay, so we're going to do if direct cast client user state, to user secure connection. So if they are in a secure connection, then we know that we need to decrypt the data. So data equals direct cast again, direct cast our client user states, user, decrypt data. Fairly simple, right? Essentially the same thing over here in our helper method. So send to client. We're still going to serialize data the same way, but right here we're going to do if they're in a secure connection, then data equals encrypt data. And then we're just going to send it along. And then right here in broadcast exclude, we also need to update this. Let's go ahead and just copy and paste this code down here really quick. Change this from client to C. Okay, so for each user that's connected to us, if they're in a secure connection, then we want to do c.send and then direct cast C. We're just going to encrypt the data that we're sending out to that specific client. Otherwise, if they're not in a secure connection, we're just going to send a regular packet out to them, just like this. And we need to update the client now. Same idea as before. If secure connection is set to true, then data equals decrypt data. We don't necessarily need a try-catch here. We're just going to kind of trust the server not to send us corrupt data. And if it does, then we have bigger issues anyways. But I'll let you guys figure out how to handle that best. Okay, and let's go ahead and update our send packet helper method up here in the client. So once again, if secure connection, then data equals encrypt data. Alright, and that should be it. Let's go ahead and test this. Rebuild our chat program. I'm sure I forgot something. Oh, I did, and I caught it. I caught it this time. Handle handshake packets. Right here in the client, I left it out. Okay, rebuild again. Dodge the bullet there, huh? Okay, debug our server. Hopefully this doesn't crash and burn. And debug our chat application here. Client side. Uh-oh. What happens? Link the data to decrypt is invalid. And where is this at? Is that re-angel manage transform final block? Okay. Actually, what project was that in? Okay, so this is client side that this issue is happening. So let's go ahead and check that out. I'm going to pause the video and look into this so you guys aren't watching me fumble around with this code for the next like 10 minutes. And we'll have it fixed here in a second. Okay guys, I'm back, and fortunately it's a pretty simple fix. First of all, I forgot to set the RSA bit here, so 2048 on the handle handshake packet. Don't forget to set that to 2048 so that it matches what's over here. Private RSA 2048. Okay. The second thing, which I actually did not take into account, is even though these packets are sent in order, in this instance, there's no way of guaranteeing that the response from the client will get to the server before the sender, before the server's message of the day packet gets to the client. So what we can do to correct this is go ahead and move the message of the day packet out of here, and we're just going to move it up into our handle handshake, our packet handler for handle handshake packet. Okay, we're just going to put it right there under prepare encryption, and this should work just fine now. So let's go ahead and rebuild our client. Okay, and run the server. And I'm going to go ahead and run 2 instances of the client. So we're getting the message of the day packet here. And one thing I do want to point out here is you can see that the sizes of these packets are quite a bit bigger. And that's because there is some padding added onto each packet. See if I send the... First, let's authorize. So root. So if I send a regular string test, you see it's sending 16 bytes because it's adding on the extra padding. So sending and receiving packets is going to be a little more processor intensive with the server and the client, but you really just need to worry about the server. And obviously it's going to use a tiny bit more bandwidth, so that those are things to keep in mind. But you really got to ask yourself if it's worth it or not to have that extra security, especially this day and age. So it is working very nicely. If you guys have any questions, just let me know. And I guess that's about the end of this video. So see you guys later.